Hello, my name is Ahmad Faris bin Ahmad Saifunazif, and my FYP project is Retrospective Dosimetry of Human Fingernail After Exposure to Ionizing Radiation under the supervision of Dr. Siti Fairus Abdul Sani. There are many instances where incidents involving ionizing radiation exposure can happen around us in places such as nuclear power plant or even hospital or scientific laboratories. The problem here is that the access to electronic dosimeter is not widespread in public to perform an on-site triage when this nuclear event happen. So this gives rise to retrospective dosimeter, and biodosimeter have become an alternative in recent studies to perform this demand. So why is nail chosen as a good biodosimeter? Nail is made up of hard alpha keratin with stable disulfide bonds, and this bond is responsible for the keratin's high resistance to chemical and enzymatic attack. Study by Hobbs in 1977 also found that hair and nail retain the highest concentration of arsenic due to the content of keratin. And in general, nail has a standardized method for collection, storage, and preparation of a sample, and is also easier to reproduce as nails grow within a week period. So the aim of this study is to utilize human fingernail as a retrospective dosimeter, and to do so, we are going to study the elemental composition of human fingernail and calculate its effective atomic number. Also going to study the structural characteristic using X-ray diffraction, and also to observe the Raman shift in shape and position as the fingernail were gamma irradiated to dose in the range of 0 to 10 gray. For the methodology, the human fingernail sample is collected from 18 different individuals, and they were categorized in 3 different age groups. The fingernail is clipped with a nail clipper, and after its use, it is sanitized to prevent any germs contamination. The sample is then annealed in the annealing oven to remove any residual background radiation, and then it is irradiated in a gamma cell machine, which is a source of cobalt-60 radioactive substance according to the latest dose rate. For the purpose of EDX analysis, scanning electron microscope was used to obtain the image of our sample at the magnification level of 200 times, and these were the images of the 3 samples which were all non-irradiated. Scanning electron microscope also provides us with the information of elemental composition in the fingernail itself, and from this information we can calculate the effective atomic number according to these 3 steps, and from the 3 samples we can conclude that effective atomic number is approximately 7 in all 3 samples. And it is also worth observing here is that the sulfur and calcium content is mostly abundant in the B group, but then it starts to decrease from the age of C group. This can be explained that as we grow older, the amount of minerals in our body decreases as we lost the appetite and also the deficiency of kidneys to retain these minerals in our body as we grow older. So the X-ray diffraction XRD is used to study the crystal structure of alpha keratin in human fingernail. This works by radiating the material with incident X-rays, and then we can measure the intensity and the scattering angles of the X-rays which is with the material. And the raw data from the diffractogram we can plot in the graph using Origin Pro software. What we can see here is that there is a single distinct maximum peak intensity at approximately 29 degrees for every radiation dose. It tells us that there is a crystalline structure from the keratin material in the nail. It can also be observed that at smaller angles between 5 to 15 degrees, the graph exhibits the slope of amorphous, which makes the fingernail a sample that exhibits both crystalline and amorphous characteristics. This agrees with the previous work of J.C. McKittrick, who described keratin as a composite material consisting of crystalline intermediate filaments which embedded in an amorphous protein matrix. So Raman effect is when a frequency shift happens as monochromatic light is interacted with a sample. This is a useful tool to study a wide range of substance because it can be used in solids, liquids, or gaseous substance. And it is also a non-contact, non-destructive approach and needs very little sample preparation. This is a couple of previous study on human fingernail using Raman spectroscopy, and in both study it includes one type of sample which is healthy and unaffected, and another sample which is affected either physically or biologically. And there is some key peaks that we can observe here. For example, in the region of 500 cm-1, there is the presence of disulfide bonds, and it is important to the nail because it is related to the mechanical properties of keratin. And in both study, it shows that sample which is healthy and unaffected reach higher peaks than the one that is affected. And another region that we can see here is around 900 cm negative 1, where it shows that healthy fingernail reach higher content of alpha helix rather than the affected sample. And the presence of amide in both studies shows that fingernail is made up of mostly carbon atoms and carbon compounds. In conclusion, human fingernail can be a good candidate for a retrospective dosimeter in case there is an accident involving ionizing radiation. And to improve on this study, we can collect a sample from a variety of population with different races, gender, or even professional job in the future. Thank you.